Hi there and welcome to this video for Senior Physics on Light and Waves. In this video we're going to look at wave interference patterns which we're going to use the PhET simulation. Okay, so basically what we're going to be looking at are the following things in our simulation. We'll look how light is being passed through a double slit and look at the fringe patterns that are going to be produced. Then we're going to look at what happens when we increase the slit separation to that fringe pattern. We're going to analyse the amplitudes of antinodes and nodes to show what's happening with respect to our constructive and destructive superpositioning. We're then going to look at the same sort of thing, but then look at the concept of sound. Again, we'll use the detector to look at the amplitudes of the antinodes and nodes so that we can interpret exactly what's going on. Okay, so let's load up the site. I'll just go to the page now. Now, I've loaded the link up on the post, so you can actually go and have a play yourself. Here we go. All right, so in this case, I'm not going to be using the wave concept. I'm going to be using light. I'm just going to open it up so you can see as bigger screen as possible. There we go. All right, so I'm going to go over to light here, and I'm going to use red light. Just open it up so you've got a nice big screen. And I'm also going to put my screen placed up on the side. Now, this is light just passing out normally. It's red light, it's monochromatic light, meaning it's of one wavelength. Now, you can see on the screen that basically we've got red light pulsing across, and as a result, the whole of the screen is covered red. Now, what we're going to do is we're going to put two slits in. So this is what Young was doing in Young's experiment. We're going to get our two slits. I'm going to put it halfway in the picture. I'm then going to load down my slit width and my slit separation. So at the moment, no light is getting through, and we can see that our screen is black. Now, what I'm going to do is I'm going to start to open up my slit width and my slit separation. Now, you'll notice that the slit separation is in nanometers because remember, light, the wavelength is really, really small. And suddenly what we're getting is a beam of light which is generated on that screen right in the center. Now remember, that's that zero order antinode which has been generated. We've then got nodes on the other side. Now what I'm going to do is I'm just going to increase my slit width and then go up through my slit separation. These are going to give us really, really good defined fringes. Now you can see that my center point now is actually generating a nice red fringe right in the middle of my zero order. But also on the outer edges of the screen, you can also see that we're getting secondary fringes which are being produced. So I've got my red in the middle here. So you can see there's my red area. Then it goes dark, and then there's my red forming again. Now this dark area is basically going to be our nodal point. This is going to be our antinodal point. Now if I take my detector and I click on my detector, what I can do is I can check what the amplitude is doing at various points. So I'm going to look there right at the center of that fringe pattern. You can see that I'm generating a nice amplitude which has been produced from my zero order antinode. Now let's move it across and we'll put it in the dark bit and watch what happens to the graph. Basically, I'm getting a flat line. Okay, that flat line is because we've got peak meeting crest. They're out of phase by 180 degrees, and as a result, we're getting no wave is being generated. So we're virtually getting down to zero. Depending on where I put it, should actually see a flat line. But it's a little awkward. Now, if I go further out again, you can see the amplitude starts increasing. So I go from an increased amplitude to a diminished amplitude, then to an increased amplitude again. And the same in the opposite direction. Diminished, and then bigger again. Okay? Notice that the amplitude at this point here is not as big as the amplitude at this point here. Remember, it's losing energy. Okay, well, I'll get rid of the detector again. So hopefully that explains what's going on. If you go and watch the explanatory videos that I've set up, will explain how that comes about. So if we increase the slit separation, okay, I'll go up notch by notch. What we'll actually see is more fringes which are going to be generated. Remember, we had a big fringe out here, then dark, then a single one. Now we're getting a secondary fringe which is being produced, and a new node is beginning to form here and here. Let's go up one more. That will go up. We'll go up to about 3/4. Now what we'll see is the waves start working together. We get these fringe patterns which are generated here. Okay, now again, if I go back to my detector, there's my initial, so my 0 order antinode. Then I go to my node, flat line. Then I go to my 1 order node, antinode, sorry. Then I go to a flat line. Then I go to my 2 order antinode. Okay, you can see the amplitude is there, but it's slightly diminished because it's losing energy. Alrighty, so let's go and put the slit separation on its biggest setting. And now you can see that we've got these fringe patterns. Although they're pretty faint, we have got fringes here, 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 and we've got nodes here, 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 and here. So what do we notice? Well, as the slits get further apart, we're actually going to get more interaction between the waves, and as a result, we're going to get more fringe patterns which are going to be generated. Okay, so that looks at light, and we've now understood what happens with light. Let's finish it off by looking at sound. So to look at sound, we just go and click up on the tab here, and there's my sound that's been generated. Now I can look at my sound being generated in 2 ways. I can look on the grayscale, as you can see here, or I can look in particle form. I'm going to up the frequency a wee bit. There we go. All right, I'll let it all settle. So my speaker is generating out a frequency. Now, if I go to the particle area, we'll see the particles of air which is going to be generated. So what we're going to do, we're going to have our wave here. Now I'm going to put in 2 speakers because I want the 2 speakers to interact with each other. I'm also going to lower the spacing. The spacing's as good as I can get it. Now what you will notice is, look at the fringe pattern which is generated here to here to here to here to here to here to here. Isn't that Young's experiment again? Now what we will notice is that when I take my detector, I can take my detector and I put it on my 0 order antinode. Look at the amplitude which is being generated. Okay, got a nice large amplitude. Now remember, this is 0 order antinode. Because it's an antinode, I've got peak meeting peak, so I've got a nice large peak which has been generated. If I move my detector now to one of these lines here, look what happens. Virtually a flat line. Now that flat line is due to destructive superpositioning. As a result, I'm producing a node. Because there's no amplitude there, what I would hear would be a diminished sound. I move across again. I go into my order 1 antinode, and you can see there's the amplitude. The amplitude goes up, which means I'm going to get a louder sound. Move across again, and we're going to get a diminished wave. Okay. Now remember, if we're looking at path difference, which is explained in the post, at this position here, it's out by 1.5 wavelengths. The distance from here to here and here to here is out by 1.5 wavelengths, and as a result, we are sitting on a node in this position here. The 2 waves, the path difference from here to here and from here to here is going to be out by half a wave, and as a result, because they're out by half a wave, they're out by 180 degrees, it's going to be diminished. Now, nice thing that we can also do with this is we can also put sound on, so you can see what's going on, but unfortunately you can't see what's happening with the detector as you move across. Okay, but you can see here that the amplitude is going to be generated. So you would hear a higher frequency generated here than you would, a louder frequency generated here than you would here. Okay, let's turn it off because it does get a little bit annoying. Alrighty, so let's just have a look again and do a comparison. If I just go to one speaker, okay, and put my detector on, see we get a nice wave which is being generated. Okay, then go to my two speakers, place it in the middle. Look how the amplitude has increased. Okay, go back to one speaker. See how the amplitude has gone down again? Go back to two speakers, and up it goes. So again, what I'm showing you there is that the waves that have been generated, because they're coherent waves, when I put two speakers in, I can actually increase the amplitude. Now, this is really, really useful, especially on things like runways. On runways, they'll put transmitters down one end of the runway, and what that will happen is they will superimpose, so down the middle of the runway, you get your highest strength. And using computers and what have you, the plane can actually fly down that runway, and if it veers to the left, you can get diminished reception. Obviously, if it veers to the right, you can get diminished reception. As a result, the pilot or the plane can actually fly straight down the middle, hit the center of that runway, even in fairly foggy conditions, or if it's windy, they can move across and adjust the plane's direction as they move through. Okay, well, I hope you found that useful. Do have a play with these. It's really good fun. But it does explain what's going on. Oh, one thing I was going to show you, and this is pretty cool. If I then go on the sound wave and go onto particles, have a look at this. I'll leave my detector on actually. These are the sound waves which are generated. But look what's happening in here. Okay, and you can see your fringe patterns which are being produced. 0 there, increase there, 0 here, and you get the idea that basically we've got very diminished sound. If you squint slightly at that picture, you can see your waveforms which have been generated. There's your antinode here, 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 and we can prove that if I put my detector bang on that line, you can see how all the particles are lining up. Okay, same sort of situation here, and probably the same one just in here. And you get that nice line which has been generated of your antinodes, and here are your nodes as we move through. Okay, so there's lots of things that we can do with this program. It's a great program. I really suggest you use it and explore it throughout your physics courses and see what they've got available for you to go away and play with. Okay, well, that's it from me for now. Do watch the explanatory videos on wave interference, path difference. They all link together. There's one more video which I will put up, which is going to be just some problem solving with path difference and wave interference. Check that out. That will show you how to deal with certain problems. Okay, well, I hope you've enjoyed this course, and thank you for watching me, and look out for the next course, which will be posted in the next few months. Thanks for watching.